So Denise, can you just for this first inequality, can you plug in 1 and 0 for us, and what does it read? Is that true? You get 1 is less than 2, so that works here. Riley, what about the next one? Plug in 1 and 0 for us, please.
You get 1 is greater than or equal to 0 minus 1.
Is that true?
Yes.
So this one's a definite yes there. All right, next one. Sam, let's do the same thing. Plug in 0, 0.
Well, for the first inequality, you get 0 is greater than 1, which is not true.
So just stop there. We're done, right? If it doesn't work for one of them, it doesn't matter, right? Because in order to be a solution, it has to work for both. Okay? So in order for it to be a solution, it has to work for both inequalities. All right, so that's just a minor topic. The main topic today is graphing, so let's talk about that. I even wrote on your notes already. We're just looking for the overlap in the shaded areas, right? So on your papers, let's start graphing these two lines. So jot down this system. This is the same system from part A of that last problem. And I'm just going to start by plotting the points. Okay, so let's start by plotting the points here. And I'm going to go this first one in purple, this next one in red. So plot the points, worry about shading later. Oh, I guess and graph the lines. Slash graph lines. We'll shade in a second. Alright, so we have that y-intercept of 3. We're going to have a dashed line here. Or sorry, y-intercept of 2. Slope of -3, dashed line. And then our other one, a y-intercept of -1, a slope of 1, and we have a solid line here. So once we get those graphed, our graph should look like this. Right, just using our graphing skills. Don't worry about shading yet. Just make sure you get those graphed.
I remember you saying we don't have to do the arrows at the end.
No, you always have to do that, 100% of the time.
Oh, because I remember you.
I've made a big deal about needing to draw those arrows. These graphs continue infinitely, so they keep going.
So when was the one where we don't put the arrows?
I can't think of one that we've done in class.
When there's only domain and like only this, and you have the equation.
Yeah, but so we never graphed those. I gave you those graphs.
Because I remember asking you a question about it.
So let's start shading here. This first one, everybody, are we going to shade above or below this purple dashed line?
Below.
Okay, so I would just make a quick note to yourself. So I'm going to shade below that purple line, so I draw that little arrow. And then this red line, are we going to shade above or below that solid red line, everybody?
Above.
So make a note to yourself. So there's multiple ways that you guys can write your answers down. So I can't show this on the board because I don't have like a pencil feature. But what you guys could do is lightly shade below, everywhere below the dashed line and everywhere above the red line. And then make it very dark where they overlap. That's one way that you guys can do it if you have a pencil. I can't do that on the board. Another way that you could do it is simply make a note. So I made a little notes to myself. Okay, we're below the dashed line, above the solid line. So where do our solutions lie? Our solutions lie in the overlap. So they're going to be right here, right? Everything in this area is a solution.
Wait, I'm confused when you said that you shade darker when they.
So you would shade darkly over this area. I cannot show that on the board because I don't have a pencil. But you guys have pencils, so I would lightly shade everywhere that's true.
Oh, okay.
Darkly shade.
So like where they both face.
Where they overlap, yes.
Okay, I get it.
Then the other way that you guys could do this, so if I were to draw a straight line here, or a dash line to kind of match this, some students would rather use something like cross-hatching. So we're shading below the dashed line, and we're shading above the solid line. And if you do it like this, it's very clear where your overlap is, right? So I just gave you 3 options on how you could do this. It doesn't matter to me. The best way is definitely just to only shade your solution area, right? That's the cleanest graph. But if it's easier for you with a pencil, it's probably easiest to lightly shade everything that's true and then make a nice dark area where they overlap. Yeah.
So if it's on a test, the only thing that we do need to shade is what you shade in green.
Yes.
Okay.
All right, so then let's just get to work. All right, so let's go over this one. Since it's an absolute value, I'll go ahead and go through it. And let's start with this first line. So make sure we know how to graph that. We got a y-intercept of 3. We have a slope of -2, so we're going to go down 2, right 1, go back the other way. And it's just less than, so we're going to have a dashed line. And we're less than again, so we're just going to shade below. Make a note to myself, we're shading below that line. Now let's graph this absolute value. Absolute value are V-shaped graphs. The parent function has a vertex at 0, 0. So this is going to tell us to go up 1. And then on the inside here, this is going to tell us to go left 1, because it's opposite what we think it should be. So our vertex goes from 0, 0 to the slope -1, 1. Then there are slope, or what we're calling slope. For the right side, that right ray, we're going to go up 1, right 1. That's the right side slope. The left side is just the negative of it. We are going to be dashed again, because it's just greater than. Dashed. Don't forget the arrows at the end of this absolute value graph. And then, because it's greater than, we are above the red line. So we're below the blue, above the red, which would then tell us that when we shade here, we should be right in here. And our solutions would look like that.